Hello everyone. So today I want to go ahead and take a moment to show you how to do transformations in the coordinate grid, and we are going to focus specifically on rotations today. So I am here in the geometry tools through GeoGebra. They are embedded into our course, into Illustrative Math Geometry, under that Math Tools tab up here at the top. Okay, so I'm right here. I have plotted one point A at 4, 1, and I've plotted a point B that is just at the origin, 0, 0. That is going to be the center for the purposes of our rotation demonstration today. So when you go down here on your tools on the left-hand side, you see this tool transform, and under that header you see a bunch of different transformations. This one here is a translation, and if you click on it, it'll tell you more. This is our rotation, our reflection, and then there's a couple others that we won't use quite as often. So today we're focusing on rotation, so I'm going to click this rotate around a point. You'll see the instructions pop up here. Select the object, the center point, and then enter the angle. So the object is my point A, 4, 1, my center point, and I want to look at if I rotate 90 degrees counterclockwise. Now let's think about that. 90 degrees is 1/4 of the way around the circle. How do I know that? Well, the whole circle is 360 degrees. So if I go ahead and plot this, we can probably envision that if we had a big circle here, this is about 1/4 of the way around if I pinwheeled point A by center of 0, 0 here. Now if you want to actually see this in action with a circle, okay, we don't need a circle to perform the rotation, but you can see that we've gone about 1/4 of the way, actually exactly 1/4 of the way around the circle. If you want to see that visually another way, I can connect my center point to the original point and that center of rotation to the image, A, and we should see a 90-degree angle. And in fact, if I measure that angle between those two segments, lots of tools to verify what I suspect here, it is in fact exactly a 90-degree angle. Okay, well, what if I want to go a different angle measure? We're going to try to come up with some rules here. So let's go down and we'll do the same thing, a rotation around a point, using point A, using the center of the origin, but this time I want to go 180 degrees. Now try to predict in your mind what that will look like. 180 degrees is halfway around the circle. So sure enough, if you look here, from this center, we would be halfway around the circle. And if we connect this here, this angle would be 180 degrees. We'll do one more transformation before we talk about patterns. So I'm going to use that same point A, the same center of the origin. This time I'm going to rotate 270 degrees counterclockwise, and 270 degrees is 3/4 of the way around the circle, so sure enough, I land down here 3/4 of the way around the circle. I'm going to connect that one more time. Let me zoom us back in so we have a little bit of a better idea of what's going on here. And then you can see my points and where they have landed. Now, I want to talk to you a little bit about some of the patterns that I notice when I look at these points. Sorry, I just want to get my grid just right so that we can see it a little bit more clearly. There we go. All right, first of all, when I'm looking at this rotation, 90 degrees around the circle counterclockwise only gets me 1/4 of the way around the circle. In terms of the graph, we can look at that in terms of the quadrants. The coordinate grid is split into 4 quadrants. Each quadrant is 90 degrees. So if I'm making a 90-degree turn, I'm going to hop from whatever quadrant I'm in into the next quadrant. So this is the first quadrant, this is the second quadrant. My 90 degrees takes me 1 quadrant counterclockwise. I can also think of that as 270 degrees, or 3/4 of the way, clockwise. Okay, so that's 1, 2, 3 quadrants hop to get to A prime that way. If I want to think about my 180, halfway around the circle, that's 2/4, 2 quadrants, right? 1, 2 quadrants to get to this point, or even going clockwise, same thing, 1, 2 quadrants to get to this point. My last point here, my 270 degrees counterclockwise, that's 1, 2, 3 quadrants, 3/4 of the way around the circle going counterclockwise, or 1 quadrant, 1/4 of the way around the circle going clockwise. Okay, so we can look at kind of a finished product here to get a sense of those measurements. So the first pattern I want you to notice is that when we look at the degrees counterclockwise versus the degrees clockwise, in order to land in the same spot, right, the whole circle is 360 degrees. So this sum, adding these numbers, will always be 360 degrees. Going 90 degrees counterclockwise will always be the same as going 270 degrees clockwise. Going 90 degrees clockwise will always be the same as 270 degrees counterclockwise. And 180 is the same either direction. The second pattern I want you to look at, though, is the actual coordinates of the points. How do I quickly get from this point to this point without necessarily tinkering with this tool every time? Okay, and what I want you to think about is how can we use the actual numbers that we see? Well, when I look from A to A prime, when I performed this 90-degree counterclockwise rotation, or 270-degree clockwise rotation, I notice that the numerical values 4 and 1 stay the same, but the location of those numbers switches places. So here x is 4 and y is 1. Here x is 1 and y is 4. Now I said x is 1, but really x is negative 1, right? So what I'm looking at right now is just the value without the sign. Positive or negative we'll talk about in a second. So it looks like when I do a 90-degree or a 270-degree rotation, those numbers switch places. Same thing for the other one, right? 90 degrees or 270 degrees the other way, 4, 1. Think of this as just like 1 and 4. Now I know it's a negative 4. We'll talk about the sign in a minute. Last little pattern that I'm noticing here is the 180 degrees. From this point to that image point, the x and y, the 4 and 1, stay the same in the same position. X is 4, y is 1. But I do again notice there's some positive negative switchovers. Okay, so there's some patterns here. For 90 and 270, we see this flip of the x and y. Okay, for 180, we don't. I want you to think a little bit about perpendicular lines and slopes and what we know about that. These are opposite reciprocal slopes. So it should kind of make sense. Reciprocal means flip the slope fraction, right? We're flipping the actual numbers. Okay, so that's kind of how I explain that pattern. Now, how do I explain the positive, negative trends? Well, I just think about the quadrant I land in. So what do I mean by that? If I take this point and I rotate one quadrant, I'm now in the second quadrant. So if I know the numbers have to be 1 and 4, but I'm looking in the second quadrant, what does x have to be? X has to be negative, and y has to be positive in order to land somewhere in that quadrant. Okay, same thing over here. If I know I'm talking about 4 and 1 to go 180 degrees, those 4 and 1 are going to stay in the same place. But if I hop 2 quadrants, I'm down here in the third quadrant, both x and y have to be negative. And to go to the fourth quadrant, if my rotation takes me there, the numbers will flip because I'm going 270 degrees counterclockwise or 90 clockwise. But looking at the signs, I know my x has to be positive and my y has to be negative. So I kind of worry about the signs at the last minute. So what does that mean for us here? Well, let's start with a blank slate and just look at like one more example. I'll show you how I got that grid in case you don't know how to pull that up. I'm going to go right under my settings, show my axes, show my grid. I just want those major grid lines. If I throw a point here at, let's say, 3, 2, okay, if I go ahead and rotate that, let's think about just a 90-degree rotation about the origin. So I need another point at the origin. I'm going to click here and click here. And before I even do it, we're going to go 90 degrees counterclockwise. I'm going to think about the coordinates. If that's 3, 2, I'm thinking 2, 3. If that is a 90-degree turn, I'm thinking 1 quadrant over. And if it has to be in this quadrant, 2, 3, I'm really thinking -2, 3. So let's see how I did. Let's actually do the rotation. Ready? Here we go. 90 degrees counterclockwise. Hopefully I land right on top of that point. And ta-da, I do. If we form this angle here, we see a 90-degree angle, we see perpendicular line segments, right? And we see those coordinates working out the way we hoped. So just to kind of sum it up, what should we expect to see here? If we see a 90-degree clockwise or 270-degree counterclockwise rotation, I'm just counting my quadrants, 1 or 3 over. If I see 270 degrees clockwise or 90-degree counterclockwise, same thing. I'm counting my quadrants. How far do I move? For both of those, I switch the x and y numerical values. I check the quadrant for the sign. 180 degrees is the special one. Either direction is the same thing because it takes us halfway around the circle. For either direction, I rotate 2 quadrants. X and y stay the same, and we just check the quadrant for the sign. We can expect some opposites to occur. So hopefully that gives you a better idea of how to deal with rotations in the coordinate grid. Keep in mind you can also always use the tools that we have in GeoGebra to check that.